operations organization. And today, I'm going to present on behalf of Verizon. We're going to talk about the Verizon Cloud Platform. I've got a couple colleagues. Elaine Wong-Perry is going to help me, and so is Amrit Kumar. They'll come up when they need to. So what we wanted to do was evolve a little bit from some previous talks that we've done, right? So today, I'll briefly describe what VCP is with an overview. I'll talk about some of the services we have, very common. I'm going to go into applications a little bit, right, and kind of talk about the maturity of the platform and the applications that are actually running on VCP today. Do an overall operations overview. We'll talk about capacity a little bit, how we deal with it, some of the tools we've built, right? So this is sort of an evolution from some previous talks that we've done about the illusion of infinite capacity, okay? So what is VCP, the Verizon Cloud Platform? It's a globally distributed platform, okay? So we are running core data centers domestically in the United States. We've got some smaller sites international, about north of 30, when I combine them. And then we've got edge sites, 52, right? Yes. We are a regionally distributed platform, right? So we decided architecturally to limit our failure domain, right? So we are basically what I refer to as our minimum mapping unit is a region, right? So that's where our failure domains for our applications, our construct there is an OpenStack region. A lot of our core sites have a lot of regions, right? So there's many regions, and then we operate them with different versions of OpenStack in different configurations. Whereas our edge sites are larger VIMs, right, with more compute. There's a lot of options for the way that you can distribute your workloads. What do we look like? What are we? So we're a private cloud. We support NFV. We support service assurance tools for the applications, but also for the infrastructure itself. We run some of our tools in VCP, but we also have a separate infrastructure where we run the OANM tools as well. We want them to be running when we have problems with our regions, right? We've got a lot of web applications. We've got some spatial analysis tools that are in there as well, right? And again, it's global in scope with a multi-region architecture. So after about, a year and a half, 2 years, we're growing up, okay? So we kind of have a feeling for what our service offerings need to be and what they need to look like. On the right-hand side of this slide, you can see we're running OpenStack pretty common services. On the left are our 3 main service products that we offer out to the business. I'll go through those for a couple minutes. Our compute, right? So we divide up with 3 different CPU models, right? We've got a standard configuration, which is basically a 3-to-1 oversubscribed CPU model. We've got performance, right, which is 1-to-1, right, so there's no oversubscription. And then our high performance is 1-to-1 CPU pinned, right? So these are offerings that we have back out for our applications. The percentages there represent to date the percentage of the applications, right, that are actually utilizing that type of compute model, CPU model. I think it's an interesting number after a couple years, right? Cloud native. We're not super cloud native. Beth is totally agreeing with me here, right? I think aspirationally, we want to get there, so therefore we have the multiple models that we offer, okay? So is that going to change? I think so. It's changing slowly, right? So from a maturity model perspective with the applications that are running on top, Amrit will talk a little bit more, but I think we'll see that change, but we're not seeing it change rapidly, okay? In terms of our network products that we have, lots of V4. Floating IPs have been tough for a lot of our applications. Again, they're getting there, the ability to use them. We've got direct attach going on, IPv6, direct attach as well, subnet pooling. We got vSwitch going as a supported product. We do a lot of SIROV, okay? Again, this is due to application requirements, right, in terms of the performance needs, okay? We've got portable IP addressing there as well, right, and we have multiple provider networks. I've got 7, right? 7 provider networks, and for various reasons, different parts of the business require. Storage, we started off doing Ceph. Ceph was not the most performant for a lot of our applications, so we're actually moving away from Ceph. We've got some NetApp stuff in there now. We've just built out our first object store in production, okay? Again, it's a requirement coming in from applications. Why are we doing that? So our patterns of use, this is interesting. Again, kind of talking about the maturity model, I think, developing my own maturity model for the platform itself, right? So we define VCP by the services we offer, right? But the services are actually defined by the applications that are coming on board, right? So that's something that we've learned over the past couple of years is very close very close relationship between the platform teams and the application teams need to exist, right? And even more so, a very tight relationship between my operations teams and my lab, right? So as that relationship has evolved, we see very, very clear patterns of use coming out of the platform. I don't know if you want to talk about this one for a second, since you made this slide, right?
Thank you.
This is Elaine.
Hi, am I on? Well, so
Turn
the
her on.
purpose of this slide is twofold, right? One is we've got applications, and Andy has already alluded to the cloudiness and the non-cloudiness of our applications. We wanted to. So we wanted to identify just where our applications fall in that spectrum.
He's coming through you.
Here we've got the 4 classifications. And secondarily, what Andy has alluded to earlier also is how much effort does it take for our operations team to configure these environments? Environments, I mean the projects, right? So to the far right, you've got almost out-of-the-box functionality. I mean, these applications will hit the ground running in the OpenStack environment the way it is established. Further to the left, and the further you go towards the left, indicates just how much customization we have to do to ensure that your applications run well on the cloud. That's my addition.
Turn me back on again. Thank you. So I think getting real about the patterns of use has been important for us to figure out how to model our operations practice. Okay, so in terms of where do we need to restrict control, right? Where do we actually need to think about standards, right? In certain portions of the platform, we've had tighter standards, say around flavor creation, flavor types, right? In other areas, we have not, right? So operationally, the maturity of the applications coming in have really affected our ability to operate at scale, okay? So we like the fact, that we can actually put, we can sort of bucket these things, and it helps us architect and build the teams out and look for skill sets to support the applications as they're running, okay? We got all kinds of audio stuff, yeah. Right. Cool. Okay, so I'm not going to go through this in depth. I mean, the presentation will be available. Have a look, right? I mean, it's interesting. If you're an application provider, and for us or other cloud, running on other clouds, you're looking at this, help, right? So one of the reasons we're here is to talk to the community, right? When I say help, I mean, moving and refactoring or rebuilding applications into smaller failure domains, breaking these old big apps up is really important, right? To run more native in these types of environments. Okay, so our service offerings are defined by our tenants, of course, right? And our features come across based upon what our customers want to buy, right? And we are seeing these things evolve, just slowly. So that's patterns of use that we see today, okay? So since I'm on an application kick a little bit, Amrith, talk about apps for a couple minutes?
All right.
I don't have a clicker.
Oh, there's no clicker. All right. Andy always makes very serious presentations. I don't like serious presentations. So we get a lot of applications, and these applications are the things which we use to let you use data on your phone, make phone calls, all of those kinds of things. And you would assume that terms like cloud native, cattle, and pets are all well understood. To Andy's earlier point, we would love to have applications come in like cattle. Everybody knows what that means, right? Shoot the thing. If it's not OK, get a new one. We would even mind if it was something slightly closer to a pet, goldfish style. Thing dies, go get a new one. What we end up getting is these things on the right. So what's a sacred pet? Anyone? Golden cow is an example, or like cat in Egypt. Do something to a cat in Egypt, you know what happens to you. The operator gets taken out. So that's the last thing we want. Unfortunately, these are the applications we end up getting. Now, try to take this application and put it on the cloud Andy was just talking about. On edge, we have much larger VIMs, one large failure domain with availability reasons. On core, we have multiple regions. And the reason is we want to have applications in such a way that if you lose an entire failure domain, you still are able to make your phone calls. So if you are refactoring applications, please start going towards cattle. And If you are working with other people's applications, join us and help push that, because otherwise we're never going to get there. Tomorrow we want to go to containers. This is going to be even worse. Everybody okay with that concept?
I just preached it yesterday. Yeah. I applaud you.
So Sacred Pets, free to use it, no trademark involved. The other place where we have a lot of trouble is automation and orchestration. We need to bring up an application. We need to bring it up quickly. We need to bring in new services. And yes, we have vendors giving us QCOW2 images, but these are huge. I started getting QCOW images which were gigabytes in size, and I was wondering why this was. Now, before I started working at Verizon, which is about 2 years ago, I used to work closer with OpenStack on the Trove project. And for those of you who know what Trove is, we do a lot with images. Fine. Some vendor gave me a QCOW2. It was huge. I took the damn thing apart. Guess what takes the most space? Temp file system. OK, how did you get temp file system into an image? Oh, we installed it onto a VM. We took a snapshot of the VM, converted it to a QCOW2, and gave it to you. Please, do not do this. OK, there are tools to do this much easier. Packer, Disk Image Builder, whatever you want to use. Make your images the right way. If you don't know how to do it, send me an email, contact address on the last page. I'll help you with that. Build your images with automation. Don't do it manually. That's great. Make them smaller, make them cleaner. And if you have a larger bloated image, you're invariably going to have a larger surface area which is vulnerable. Services which you don't need. Random passwords for users who you didn't know were on there. Static passwords. Okay. Another concept which we've found really useful is this concept of a scorecard. We buy applications for a number of vendors. We rate these applications on a regular basis, and we go back to the vendor and we give them a score. Now, giving presentations like this moves the needle only so much. When you give somebody an F, it moves the needle a heck of a lot more. We actually use scorecards with our vendors as a means of giving clear feedback on what it is works and doesn't work. All things which are work good for us. What else? How many of you have a situation where you instantiate a VM, and then before the VM can take traffic, you have to log in and do something to it? OK. Not a good idea.
Config.
You need to use some kind of automation, any kind of automation, so when your orchestrator spins up a VM, it comes up and takes traffic, or sits standby, whatever. A person with an employee ID and a badge is not automation. Okay? Unfortunately, in a lot of cases, we have images which have no software on them, and a person logs in and installs it by hand. Maybe that's what you used to do in the physical function world. Not going to scale in the virtual world. So please don't do that. There's any number of ways in which you can do these things. You can use Cloud Init. You can inject your configuration. You can store it in some place. You can use service discovery. Do something other than logging into your VMs and trying to configure them by hand. All right? Stop me anytime if you have questions. And the last one about VMs. We'll talk a little bit why people do this, but sometimes people come up with VMs which are like enormously sized. I need a 16-core VM. What are you going to do in the 16-core VM? Oh, it's really, really complicated stuff. It's going to burn that CPU. It's like, great, we spin the thing up. If the thing is going full blast, it's probably using 5%. Why? Use smaller VMs. Use more of them if you want to. One of the functions which we do provide on our cloud, it's turned out to be really good, at least on the core side, we have network-attached storage, and we allow you to migrate a VM. Migrating a large VM really sucks. Migrating small VMs actually can work. So think about that if you want to offer the service. If it is something you want to offer, have smaller VMs. Really helps. And make your application scale horizontally. If you're building an application where in order to process more transactions, you need more CPUs and more memory in the same VM, you're probably doing something you want to think about. How can you scale horizontally and have more VMs? Okay? So switching gears a little bit, I talked about why people ask me for 16-core and 32-core VMs. We give application vendors, or we look for applications which can satisfy some amount of TPS. I kid you not, this is actually something which I've seen happen. In a lab, test way over there, one configuration, and then linearly extrapolate. How many of you have ever linear extrapolated with one data point? Geez, you laugh, right? Okay. I've seen this being done. When you do that, and part of this might sound funny, but the reason why that doesn't work is when you linearly extrapolate with a single data point, you're multiplying your fixed cost as well. Typically, your application cost is going to be some fixed and some variable. If you tested a very small configuration and you just multiply it out, you're scaling your fixed cost, which is ridiculous. The other thing which I notice a lot of people do is they test only an application running in normal mode with no failures. How many of you enable hyperthreading on your cloud? That's it? Seriously? The rest of you don't know that you enable hyperthreading, or you know that you don't enable hyperthreading? They don't enable hyperthreading. They don't know. Right. That would be my guess. But how many of you are running scientific workloads or very high number crunching kind of workloads? Yeah, the rest of you probably have hyperthreading enabled. With hyperthreading, if you have an application which is processing some throughput and running your system at 40% busy, if you double the throughput, I will guarantee your CPU utilization will go more than 80. Or you won't manage to double your throughput. That's because adding an extra hyperthread and starting to schedule the sibling thread will not give you one-for-one performance improvement. Somewhere here, there's a guy called Kent Gordon who's one of my coworkers, and he will tell you in great gory detail down to how the electron moves why that's the case. But if you have this situation where people are literally treating their SMT hosts as 40 cores, which is 2 times 20 cores, it is not going to work that way. So think about that one. And the last thing I'd say is, if you are using any application which has a database, please actually test your database with a realistic workload and do it at scale. Do not use an off-the-shelf, canned benchmark like, say, this one. So this is these are not actual numbers. These are representative numbers of something which happened very recently. We had a vendor who came to us with sizing for an application and a database, and they told me how many nodes they needed for the database. And believe me, it was a large number. And I asked them why. And they gave me this detailed benchmark, nice report, neatly bound, great fonts, great colors. You dig deep enough into it, you find that the benchmark which they used was some industry standard benchmark, where if you had, say, 1 billion rows of data, the probability of reading any one of those rows of data during the course of the benchmark was almost the same. Shown on the left there, no matter what the age of the data is, the probability of access is exactly the same. So if I want to get 98% of my requests satisfied by something in memory, I need to have 98% of the data in memory, right? Unfortunately, the application's real workload looks like the picture on the right. We access the data most often within the first 2 minutes of the data landing in the database, and after that, it's a very long tail, but it's really flat. Notice the y-axes have different percentages on there. On the left-hand side, the axes go 0 to 100%. 40% of the data is accessed within the first couple of minutes. Now, if I want to do the exact same 98% of data coming from memory, how much cache do I need? Peanuts by comparison. So if you're actually going to go size your database or size your application based on the one on the left, you will have exactly those 32-core VMs sitting there, with nothing to do most of the time. You can get a much more efficient operation on the right. Okay? I think that's probably all I got. And before I hand it back to Elaine, all of the things which I've talked about drive the amount of resource which we think an application is going to need. Our applications don't take the same load during the day as they do in the night. Therefore, it's really important for us to figure out this bin packing problem, which has also got a time dimension. So that's the fun problem which Elaine's going to talk to you about.
I won't do that topic justice, Amrit. But what I'll talk about is why is it important for you to know your capacity, right? So for us, our cloud environment now is in day 2 operations. We're operating at scale. We're in triple-digit count of regions, right? And these are individual OpenStack deployments that we have. I want to know in the audience, how many times have you, if you're an operator, had to do a project list just to figure out the directory listing of who is in the cloud, right? But tooling is important. And to Andy's presentation that was made 2 years ago in Boston about the illusions of infinite capacity, really the crux of realizing that illusion is understanding supply and demand model. That's not a new concept, right? It's a tried and true model that all goods and services companies and firms utilize to understand how much inventory, just exactly how much they have on hand, how much they need to shore up on, when, what to stock. Our services and goods here in the cloud platform are network, storage, and shared computing goods offered to our application users and owners. So at any given point, if we want to realize that illusion and help to sustain it, we must maintain valid information. And here you see a composite of both planning data and operations data. At any given point, you want to know, across the numerous regions that you have, in aggregate, just how much capacity you have, how much is in use, and then what is the expected capacity that's coming in from forecast data. Our planners, our planning partners here in the audience helps significantly with that piece. So the point being, the drivers to the illusion of infinite capacity is having this model and refining it with unique information for what we do. That's our business, the telecom industry, and then the VNFs and the type of applications that we run on our cloud. We continually refine that model, and we're driving effectiveness into this model, right? So that we can properly advise on builds and also anticipate applications that are coming on board. In addition to planning, knowing capacity, in addition to that planning portion is managing what you've got. So this is the day-to-day of my team. We know what's coming down the pipeline, and this is now about working with that pipeline. I spoke to the directory listing, and now when you have more than a handful, when you're into the hundreds of regions, how do you effectively search for that capacity so that you can onboard that next project, right? You need to know. You need to have this information readily at hand. You need to know who's on the regions, exactly what their capacity utilization is, what they're using, and then determine, and I call this the first pass at placing that tenant. And I'll explain why. So you're very familiar with, at top right corner, the project creation process, right? You know how much quota these projects will take up. My question to the audience is, and you may or may not know this, is that in terms of instantiation success, and particularly with the pets, with the patterns of use, those that have a higher demand for customization, CPU pinning, SROV, crossing NUMA nodes. I think the gentleman up here talked about it this morning. How certain can you be, based on just the quota parameters, that you're going to be successful in instantiating your entire deployment? I just need yes or no hands. No. And that's exactly what we're faced with today, right? Servicing pets and their special needs require that we dig deeper into solving these problems. And I've affectionately coined these problems as a relative fit problem. That's not to say that we can't, these are not insurmountable problems, and they can be overcome. Only challenge right now is where VNFs are keeping pace with how we're deploying the platforms, and then on the flip side, how operations, our team, is opening up services to the VNF applications. It creates a challenge that, that could produce friction. And here's, and I'll talk to 3 examples, concrete examples, where this relative fit issue can come up and cause instantiations to fail. 1, you've got quota, and you know how much, roughly how much capacity your regions can supply. That's good. But what the quota doesn't show you, and what OpenStack cannot see offhand, is how the operator have chosen to configure the underlying infrastructure, right? I mean, based on the demands of the applications, our very special pets and sacred pets, we can segment. We can end up segmenting and creating various host aggregates that Andy spoke to. We call that CPU model. But the OpenStack mechanisms to support those CPU models is by host ags, by AZs, your availability zones, and then you can configure non-uniform over subscription ratios, right? You need standard. Out of the box, it's 16:1 OpenStack. You'll go somewhere between 1 to 16 to service the needs of your applications. It requires that you understand what the demands are and the characteristics of your VNFs. You may have the cloud segmented to also deal with or service the demands for CPU pinning. Huge pages. Taking maximum advantage of hyper-threading and dual sockets. You want all that. OpenStack, though, has one single quota metric. How is it to know when your deployment comes in which pool of resources it's going to use? It doesn't. So it requires that you dive deeper into understanding the deployments that are coming in. Relative fit factor number 1. All right, so secondary to that is what Amrit already talked about. It's really the relationship of your virtual machines, the guest VMs, compared to the sizing or the capacity of your host. Right, so the bigger the VMs, and the more of them you need to deploy within a single deployment, and the busier the regions are, it's highly congested, meaning that most of your compute hosts are taken up by guest VMs, you're going to be challenged for this next deployment that comes in to find enough accommodating hosts, right? And so I'll qualify it with accommodating hosts. How many of you have tried to spun up a VM and you get a message that says, no host found, right? There you go, no valid host found. This is one of those situations. So our applications should seek to size down and spread wide, right? So it's reinforcing what Amrit just talked about. Quota can remain consistent and the same, but you have more of them, maybe half the size. It's gonna, when it comes to scheduling, you're gonna have a better chance and a higher probability of finding accommodating hosts. Factor number 2. And my last factor that is really based on the observation of the kind of VNFs that are coming into us is affinity and anti-affinity rules, which is my favorite. You have certain functions that needs to be on the same host. You have others that you need to keep at bay, away, dispersed from these key functions. Some deployments, and I call this a relative problem, is that some deployments, depending on how many hosts, or how many VMs, pardon me, you want to deploy, it can have very intricate anti-affinity and affinity rules. You can have 50 of them for a deployment of 70 VMs. And you can span a range of 30 hosts within your region. Now, as an operator and a deployer of these stacks, it really depends on, to solve it, how willing are you to grow those regions, right? That solves it. So I think in wrapping up with this relative fit problem, there are ways around it, and there are proposed solutions, but we're really at a point where we've got permanent residents. The VNFs have migrated off of their PNFs, and they're in the cloud. But they haven't quite just yet earned their citizenship. There's still work required to bridge that. The work of redesigning, taking a new approach, decoupling aspects, decomposing, finding ways to create or figure out the interprocess communication. That's heavy lifting. But that is an earned right of a citizen on the cloud, isn't it? So I think with that said, I end my piece, and I hand this back to Andy.
Yeah, thanks, Aline. So I think what I'm going to do is, I apologize in advance for this being somewhat rapid, but we've done a number of things. And trailing off what Aline was showing, operating OpenStack at a large scale with a lot of regions, we've had to do some tooling, right? So these are tools that don't necessarily exist, right, within the community. So I wanted to share some of that with you. The way I think of it is I've got a number of regions, right? I've got operations teams that need to look, and they need to see what is going on in those regions at any given time, right? So there's essentially health, right? There's performance, there's health, there's availability, right? There's general things that we need to know about telemetry coming off of those regions. So we collect things, right? We use open source tool, Isinga2, to do this, right? But it's really not a super smart tool. It's really just looking for events, right? So it's collecting information, which allows me to take action, right, on the results of particular events. I'll dig a little bit more into what I mean. But then I can transform that information and do things with it, right? So it could be something as simple as I lose a DIMM in a machine, right? Or some kind of environmental problem in a data center. It could be a problem with OpenStack. It could be a Galera problem, right? It could be a rabbit problem. We never have rabbit problems. Anyway, right? At least I got a couple chuckles on that one. So we transform the data. We do things with it. There are certain things that we will just go off and auto-remediate. We'll automatically ticket it and fix it, right, with code, right? Because we know what it is. We have a good understanding, for how to remediate it. I track it. I'm waiting for my next release for my provider to fix that bug, right? Or we're waiting for a bug to fix it, okay? I also categorize things here because I might notify. So our notification platform to the on-call practice comes at this stage, right? We're able to actually alarm, right, or give visibility into the operators that are actually hands on a screen, hands on keys, actually fixing things 24/7 all year, okay? We also do a bunch of aggregation, right? So there's a single surface that we've constructed. We call it the VCP API, right? It's actually a CLI, right, where the operators can type commands and it will return health information about all of our regions, right? It'll also return things like the version, right, when it was loaded. There's a lot of different information that we've coded into this. We also use GIS to aggregate things and visualize them. So on the right-hand column, you'll see a map in the lower right-hand corner. right? Visually seeing the health and status of our regions at any given time is very important. Can immediately respond to events that are occurring. So that presentation tier is important to me as well, right? Being able to quickly manifest and visualize what's going on so our NOCs can take action, right, on a particular event. This is a little detail on how we actually do collection, right? So it's essentially, it's an environment in and of itself, right? In the early days, we ran these tools within the platform itself, and we realized this probably wasn't the best idea, right? So we've decoupled that into its own bare metal environment, where this is where we set up those events, okay? And then we replicate, so it's a highly redundant environment. It's a highly available environment that my operations teams can rely on. And there is a team that supports this, okay? Again, with the transformation, there's regular checks that we can spin up. We can kill them when we don't need them anymore. But these are real checks, like let me spin up a VM, validate that the VM's there, validate the network, and then kill it, right? I can also do things like chat ops things as well, right? So if I auto-remediate something with Slack-like functionality, I'll call it, right? I can actually notify the operators or notify a customer that something has happened on an underlying compute node in real time quickly. Again, the aggregation I went through, we pull things together. The VCP API is extremely important to us. We followed the design pattern with which OpenStack uses. It looks and feels like OpenStack when you're on the command line, okay? It's an API-driven approach. There's a number of different APIs that are actually just collecting information. And again, that aggregation of all the information together, making it accessible via the CLI is sort of that special sauce, okay? Again, there's information about the region's health. There's information about the status of the services, okay? There's metrics that are in there, okay? A lot of vision for this, right? Orchestration will use this. Third-party applications can use this. We actually use it within some of our checks as well, right? What Elaine was showing you was what I've spoken of in the past. It was the result of using something called a metering platform as well, right? This is not a core, this is not a big tent. This is not a first-class citizen OpenStack. It's another application that runs that our teams have built, right? It's really neat. It's the data we can't live without anymore. It's basically how we account for everything that's being used, provisioned, right, by all of the tenants across the surface of the entire fleet, okay? This information manifests itself in a website, right, with multiple different operations views, okay, and also in the map. So I'm pausing here a little bit for effect, right, because we are also tooling around with what parts of this are open sourceable, right? What parts of this make sense to kick back out, right, and to build a small little community around within the OpenStack community itself, right? So if you're curious, interested, and you want to talk more about that, please see myself or any of my colleagues, right? There's a bunch of Verizon folks that are around. If they don't know exactly what the VCP API is, they'll know how to find me, right? But I think this is interesting, right, for the community, right? So again, we plead back out to you, those of us that help us with the community, that to always keep operations in mind. Right? Please. Okay, VCP API. Here's just what it looks like. Okay, so you can see some of the syntax. You can see the command tree itself. Okay. It's funny, since this tool went into use, when this tool becomes unavailable for some reason, it's about as important as our OpenStack services are themselves, right? So we've had to really harden this thing and make sure that it's highly available as well, right? We do love it. Okay. And like I mentioned earlier, we do spatially enable all of the regional health and status, so it does manifest in a dashboard, which is actually a map. The map itself has events that are driven to it in real time from across my entire fleet, global fleet, okay? And those alarms that manifest in the map are actionable, right? So you can actually click through the alarms within the map, and you'll be presented either through DRAC, through our management plane on our Dell servers, right? We can be presented or SSH'd into a shell, right, into the box where the alarm is coming from. Our whole ethos here is to get to fix the thing that's happening as fast as we possibly can, and spatially enabling and bringing all this together into one place has been really helpful for a fairly small team supporting an awful lot of infrastructure and an awful lot of applications. We also envision that all of the tools we build internally on the team, the things we do, the things that are manifesting for our operators should also be available for our NFVs, right? So as we evolve, mature here, there's going to be a number of tools I think that are going to be interesting for applications to embed on their own. Okay, I made up for some time. How much time do I have? It's 3:10, isn't it?
You're wearing the Steve Jobs shirt. Your one more thing should be like.
There's no thing going on here around my neck.
Okay, but true. But the GitHub for all of these tools for everyone is.
It's GitHub.
Well, no, I'm just saying wherever you guys could share, I would recommend it. As a tenant of
Sure.
with golden koi and golden cattle into at least goldfish.
Sure.
I can say you guys are doing a great job, and I know that tooling is huge, so
Yeah.
you could definitely make use of that.
Cool, let's do it, right? Let's figure out what parts of it make sense to break off and push out there. I mean, I really wasn't ready to talk about this in the last summit. I've been kind of like, okay, is this the summit? Is this the time? Is it here? We're here, right? Yeah. Operating this stuff at this scale, and listen, I'm also heavily involved in the far edge stuff, and a lot of my peers here. As we go to more nodes, it's just more nodes, right? So it shouldn't be scary, right, to the community to manage, more nodes, because if the nodes are the same and we know what they are, we've got nice tools, right, to do this with. And I know that's not a core tenet, great word, Andy, tenet for the foundation itself or for the community, but keeping operations in mind in this manner, I think, is super important. So we can take questions if I'm overrun, I think. We'll stay here for a few minutes. Sure. We'll do it that way? Cool. All right. Thank you. Have a great afternoon. Appreciate it.